This is lesson 118, and we're ready to go. Practicing point-by-point transformations. Okay, what do you notice? What do we wonder? All right, well, we got a hexagon here. 1, 2, 3, 4, 5, 6 sides. Hexagon. We got some like hockey stick shaped things, maybe. One of them's ABC, one of them's DEF, and one of them's this dotted thing. I don't know. This is kind of weird. I don't know. Okay. I notice that. I noticed those things. I wonder what we're going to be doing here, because yeah, looks kind of weird. Okay. Don't know what we're going to be doing. Okay, for each diagram, find a sequence of translations and rotations that take the original figure to the image, so that if done physically, the figure would not touch any of the solid obstacles and would not leave the diagram. So you can't go, you got to try and get A, B, C to land on D, E, F, and you're not allowed to go like outside of the picture here, okay? And you're not allowed to touch this hexagon by moving through it. Okay, so how are we going to do this? Let's see. There's going to be a rotation involved. I mean, C has to land where F is, right? And A has to land where D is, and B has to land where E is. If I just, move A directly over to D, it's going to smash into this hexagon, and it's not going to work. So we got to come up with another idea. How about if we move this over so that C lands on F, and then maybe we can rotate it a little bit. So let's try that. So we're going to translate by vector. I'm going to translate this object here, and I'm going to go from C to F. Now, notice I could click on C and click on F, but I'm also noticing that these dots are all exactly the same distance away from each other. So if I go 1, 2, 3 gaps, 3 steps, I can go from here to here. Right, let's say here, from here to there. No, I guess not. All right, I guess I'm going to have to go directly from this to this. Oh boy, that's not good. All right, let me undo that. That's wrong. Okay, something weird is going on with this. Let me refresh this page. All right. Let's see. Okay, so we are going to try to translate by vector. We're going to translate this object from C to F. There we go. Okay, done. So now I think we have to rotate this down, and just to make sure that it's going to work, let's see what happens when we have this as our radius. Yeah, see? A prime is going to rotate down here. If I use this C prime as my center of rotation, notice that this circle, the edge of this circle, does not hit this hexagon. So when this rotates around, it's going to hit right there at D. So I thought that was a good way to check that. So here we go. We're going to rotate around a point. We're going to rotate this object right here. Notice I'm not clicking on the points. I'm clicking on the object itself. Use this as my center of rotation. Uh-oh. How many degrees is that going to be? Well, I think it's 60 degrees, because we know it's less than 90, right? Because if it was 90, then this would be straight up and down, right? From B to C. So it's got to be less. And notice that these are if I connect these dots of these it would make triangles, and they're all exactly the same. So they would be equilateral triangles. So I'm going to go in equiangular triangles. So I'm going to go 60 degrees, and let's see if I'm going this way. That's the opposite of the way the clock goes, so that's counterclockwise. Let's see if we get that right. Yes, we did. Congratulations. Awesome. All right. Now we got to do the same thing over here. Take GHI to JKL. Well, if I try to do that, look at what happens, right? I can't just slide it directly over because these are going to smash into the edges here, right? They're going to smash into those. So I don't want to do that. So what can we do? Well, I guess we can rotate it a little bit. So maybe rotate it upwards a little, like rotate it using I as a pivot point, maybe, or H as a pivot point. Let's use I. Okay, so we're going to rotate around a point. We'll rotate this object around this point here, and notice this is again going to be 60 degrees because we're only going one triangle over, right? So there, this is the triangle I was talking about, right? We're going from this dot to that dot. That's 60 degrees because if you look at it, like you would go, if this was your center point here, let me just put a point here and we can talk about this. Hey, yeah, that, right? So there we go. If this point, right, if I was here, I go 1, 2, 3, 4, 5, 6. I'm back to my start. That means that it's 6 steps around. 360 degrees divided by 6 would be 60. Oops. Don't want to get rid of that. There we go. Okay, so now how do I get this thing to move without smashing into things? Let's see. How about if we move, can we move H up to K? Let's see. If we move H up to K, that's like going straight up this way. I'm going to have this. This looks fine, but that means that I is going to go right there, and I think that's doesn't count. That's going to smash into that. I don't want that. Okay. Keep getting rid of my steps there. All right, so maybe we'll move it over one. So we'll translate by vector. Translate this object from here over to here. There we go. Okay, now, so now we have this hockey stick thing right here. I think that we can get this point right here to go right up there. And then we can rotate it, and I think we'll be good. So let's do that. So we're going to translate again. Translate this object from here up to here. And now if we rotate, again, we're rotating just one dot over so that we're going to rotate around this point. The letters are all covering each other, so it's hard to tell what's what. But here's my object. Here's my center of rotation. I'm going 60 degrees. And I'm going to go, let's see, this way. So that is the wrong way around a clock, so that's counterclockwise. Boom. There we go. We covered it up perfectly. Maybe took extra steps, but whatever. All right, create your own obstacle course and then find somebody else to solve it. That looks kind of fun. But we're not doing that because I'm not going to have my cat try that, or my dog. All right, for each question, describe a sequence of translations, rotations, and reflection that will take parallelogram A, B, C, D to parallelogram A prime, B prime, C prime, D prime. All right, so how do I get this blue one to sit perfectly on that one? All right, here we go. First thing I'm going to do is I'm going to see that A needs to go to A prime, just because that's an easy way to start. Let's try that. Here we go. Translate this object from A to A prime. All right, and now I'm going to rotate this up because I want D to land on D. So I'm going to rotate this object around this point because that's the point that I already matched up. And whoops, I don't know the angle. So we're going to have to measure this angle. So we want D to land right here on that point. So we have to measure that angle. So this is the angle measuring tool. So I'm going to click on, let's see, I need to use the right hand rule. So this point, and then A, and then this point right here. And it's difficult to read because it's got a bunch of letters next to it. Can I move these things out of the way? No, won't let me. What the heck is that? Is that a 97 or is that an 87? I think that's 87.337. So that's what we're going to try. 87.337. Here we go. So we're going to rotate this around this point by, oh boy, I hope I can remember that number, 87.337. And we want to go this way, so that's counterclockwise. Let's see if it works. Hey, we got it. Yep, landed perfectly on there. Probably could have also done from B to B, right? B-A-B. That probably would have allowed us to measure that angle. So we can try that from B to A up to B. Yeah, same thing, but again, it's covered by the letter. It's very difficult to read. Okay, so what did we do? We translated point A to point A. We rotated counterclockwise by angle B, A, B prime, or D, A, D prime. And that got us there. Great. All right. Describe a sequence of translations. So we have to do another one. Okay? So here we go. Again, blue one to green one. This time, how about we... Oh, this time we have to do something different, right? Because if I move D to D prime, right, and then A moves over to A prime, it's not going to be covering it. So there's going to be a reflection involved, right? So there's going to be an extra step. So here we go. Starting off, we will translate this from D to D prime, and that slides it over. Then I'm going to rotate it. I'm going to rotate this object. Oh, you know what? We need to measure it first because we don't know this angle yet. So we're going to go from this A prime to that D prime and then up there to that A prime. And it's going to tell us a number that we still can't read because the letter's in the way. And I can't move the letter either. Is that 27.6784, I think. 27.6784. So let's try it out. 27.6784, I think. And we're going this way, so that's counterclockwise. All right, so it looks like I think we kind of did it. All right, let's see what happens when we reflect it across there. So we're going to reflect this object across this edge right here. Oh, got it. Done. Ta-da. So in this unit, we've been focusing on rigid transformations in 2 dimensions. By thinking carefully about precise definitions, we can extend many of these ideas into 3 dimensions. How could you define rotations, reflections, and translations in 3 dimensions? Whew. Well, one thing I can tell you is that it gets complicated really quickly because it's not just pieces of paper on a table anymore. It's like things floating in space, and it gets super complicated because you add this whole other dimension, right? Anyway, but it comes in handy if you want to be a game designer or, somebody who does computer animation or anything like that. Or if you want to work with NASA, because everything moves in space, right? Anyway, that's a bonus question anyway, but something to think about. That was lesson 118.